Hi, year nines, and for anyone that's coming into the channel to join us, this is basically the second video that I've made to review the end of year assessment. So this is the second assessment, made up of roughly around about 10 multiple choice questions, and around about 20 marks worth of short-term, slightly extended response questions. And this is pretty much where I would expect students to be by the end of their first year. We're following the Cambridge iGCSE course as well. So thank you very much, and hope that you enjoy the review. And what I'll also try and do is I'll also try and enable us to have a look and give an idea in a sense of where the weaknesses were and kind of like the thinking behind strategies for improving exam technique as and when we come across them. So without further ado, let's progress. So the first question was talking about exothermic reactions and talking about the temperature that's in the surroundings. The temperature always goes up in an exothermic reaction. The actual energy change that shows that this overall reaction is exothermic is A. B is bond breaking, and C is bond making. And you'll always get B and C taking place, but C is larger than B, and it gives an overall energy change, an overall change which is a release of energy to the surroundings, and that's indicated by A. If A was upwards, then it would be an endothermic reaction, even though B is always going to be up and C is always going to be down. So this is actually a really good question because it went straight for testing knowledge on energy level profiles. This is actually quite a challenging topic. So being able to identify and interpret diagrams like this is actually part of the supplementary course. For the next question, it was a rate of reaction, and the one choice that allows the rate of reaction to be increased is by making the acid more concentrated. So the correct answer is B. The next question, this was quite a twisty question, this one. So 3 students talking about why increasing temperature increases the rate of chemical reaction. Now, student X is talking about heat makes the particles expand so they are closer together and collide more often. Well, no. Heat makes the particles move faster. The particles stay as their original size. So X is clearly wrong. Why heat makes the particles move faster so they collide more often? There you go. So that person is correct. And student Z, heat makes the particles move faster so they hit each other harder and are more likely to react and thus give successful collisions. So I like student Z's answer more than Y, but both of them are correct. So the correct response for this is C. So which temperature interval is the least gas given off? So basically what you needed to do is you needed to spot the starting point and the end point, and you needed to try and figure out the smallest change in volume of gas. Okay, so clearly with D, it's the smallest rise. If you look across there, okay, and then with C, it's slightly larger, and then with B, it's definitely larger, and with A, it's very, very predominant. So A has the largest amount of gas given off. D has the least amount given off in that time period, indicating that the reaction is slowest in that period. So the correct answer was D. Sulfur dioxide, industrial chemistry, very common theme that comes up in iGCSE chemistry. Well, the pH is below 7, and the effect on litmus paper is blue to red, so the correct answer is B. The nice thing about that question is that it also touches upon acidic oxides, and it also touches upon acids as well. So it's a lot of nice topics that this particular one touches upon. I did like that question. Now, this was my favorite question of the entire paper, and the reason why I liked this question is because I knew that a lot of people would actually get this wrong. The reason being that people would have just gone into this question thinking that this is a rate of reaction question, and and what would have happened would have been like there would have been a fizzing in this reaction, and the mass decreases, and later on in the reaction, the concentration of the acid is lower, so you'd kind of like get that curve going. But the twist in this question was that the sulfuric acid reacts with the copper oxide. Yeah, that's absolutely fine, but no gas is actually produced. Copper oxide reacts with sulfuric acid to form copper sulfate and water, and all of those stay within the beaker. The clue in the question was the fact that there's no cotton wool inside the flask. If there was a gas that was released, then chemically what you would do is you would have like a light cotton wool plug at the top of that conical flask, and it would stop the liquid from escaping, so the balance could accurately measure the mass. So this is actually a really, really good question. I loved this question. And the graph that you would actually expect to have is no change in mass over time. So the correct answer would have been A. The biggest mistake that people went for was C. But yeah, the correct answer was A, no mass change. The next question was a very tricky question because you actually had to have a really good understanding of dissociation of acids for this one, which is a supplementary topic. So, which statement about 1 molar solution of ethanoic acid is true? Now, this is the fact of the matter. The fact is that it's given in the first line. Ethanoic acid is a weak acid, so there's a very small amount of dissociation, if at all, right? So, a more concentrated solution would not be weak. Well, that's incorrect because it's a weak acid. The weakness of an acid is not related to the concentration. You can have a weak concentrated acid. You can also have a weak dilute acid. So A is out of the picture. It will not react with magnesium rubber. No, actually it is an acid. It is a weak acid. So you do have some small amounts of dissociation. It would happen very slowly, but at the same time you would have magnesium reacting with this acid to form magnesium ethanoate actually, and hydrogen. So it would actually react as a normal as one would normally expect an acid to react with a metal, albeit very slowly. C is clearly not right because pHs of acids are less than 7, not greater. So the final answer is the correct answer. It will have fewer hydrogen ions than a 1 molar 1 mole per decimeter cube hydrochloric acid solution. That's absolutely correct because hydrochloric acid is a strong acid, so the extent of dissociation, the way in which that splits up is far greater within the solution. The concentrations of the actual acid particles is the same, but it doesn't denote the actual concentration of the hydrogen ions that are in the solution. Then the number of hydrogen ions that you would expect in 1 molar ethanoic acid would be much lower because it is a weak acid, so the dissociation doesn't take place to that extent. So D is the correct answer. Lovely, lovely question because it's distinguished between C grade students and B A star. Carbon dioxide is a weakly acidic one, so A is not the right answer. Carbon monoxide is actually neutral. Magnesium oxide is basic. Zinc oxide is actually one of the amphoteric oxides that we've studied, so C is the correct answer for this question. Acid plus base reacts to form salt plus water. Easy one. B is the correct answer. Okay, the next question. When a chemical reaction takes place, bonds are broken and then reformed. Which of these two processes endothermic? So we'll think back to the question that we had before. Whenever you break bonds, you're actually putting in energy into your reaction. So that process is the endothermic one. Bond breaking. Okay, so bond energies was actually the theme, and it's quite cool because this looks like 007, this little spotlight there, but I digress. The correct answer for this question is 818. We ignored the sign because we're talking about change in energy. We didn't want to punish you for the question that follows as well. But bond energies to calculate the energy change. So the first step that you needed to do was you needed to multiply by 413. And then you needed to identify that 498 was the O double bond O. So 2 times 498 plus 4 times 413. So you could just, even just estimate that. That's around about 1,000. 4 times 4 is 16. So you'd get an answer which is roughly 2,600. The actual correct answer is 2,648. If it was any different to that number, you lost the first mark. Then for the second stage, you needed to figure out how much energy was produced in the exothermic step for forming your product. So you had two of these, which is 805, so that's 1610. And then you had four of these. Sometimes some people dropped a mark because they didn't realize that there were four of them. They thought it was two because it's H2A. But you have four of these. So this is double that, that's about 900, and then double it again, you get about 1800, and then you add 1600 to it, so it's about 3400. That's your rough figures. So whenever my tip would be really good at your mental arithmetic. When you do these questions, try and figure out how much your bond breaking step is, your bond making step is, and then do a rough calculation, and then do the actual calculation. Show you working out, and then you know that you're immediately you've immediately lost marks if you're very far away. So that allows you to check your answers again. So for bond forming, you should have 3466. Again, it had to be right on the money there. And then what you needed to do is you needed to calculate the reactants. So you did that in the first step, calculate the products, and then subtract the products from the reactants, and you got 818 as your final answer. Now, if you had calculated a figure which was a negative figure, I needed you to say that it was exothermic because the bond forming stage released more energy than the energy required for breaking the bonds. If you messed up your calculation in the first part of the question, and you weren't penalised for that. If you came up with a positive number, then you needed in that calculation, then you needed to justify your answer. So you could have actually got the first part wrong, but still got the mark in the second one, in all fairness. So this next question was about observation. So we've been doing tests on cations and anions and on gases as well, flame tests too. To the fourth portion, excess sodium hydroxide was added. Now this did actually have in the question the fact that this was copper 2 oxide. The use of crusty the clown, by the way, is an inside joke with one of the groups that I teach. They dared me to have a clown somewhere in the paper, and I was more than happy to oblige. But so we have solid S, which is copper oxide. If you add the sodium hydroxide to it, you should get a blue precipitate. The key to this question was to understand that the solution that's being tested is actually the solution that's being produced as a result of the experiment that's happening in step C. So copper oxide is being reacted with sulfuric acid, which is actually something that you would have come across in key stage 3. So this is the action of this is basically the preparation of pure copper sulfate crystals, and so the solution does have copper sulfate in. It's got copper ions in, and that's what triggers off the blue precipitate. In the next question, you add a small amount of aqueous ammonia solution, and the hydroxide ions that are naturally present in ammonium hydroxide, which is aqueous ammonia, would trigger off the blue precipitate again. But when you add excess ammonia, that then redissolves because you've actually got a slightly complex ion that forms. You have the ammonia actually binding with the copper. Now, the good news is that you don't need to worry about the formulas of that. You just need to worry about the observations. And so what I was expecting when you have excess ammonia solution is that the precipitate dissolves, so you don't have any solid it's remaining behind. It turns in a beautiful blue, royal blue, a dark blue color. That's one of the nicest colors that you have in chemistry. Okay, the next question talked about basically talked about the sulfate test. So you add dilute hydrochloric acid first, because just in case there's a carbonate in there, which could actually trigger off a false reading. And then you have barium chloride added after that. So a white precipitate is actually what you're looking out for. If we go back to the question, we can see that a splint is relit when you have the hydrogen peroxide added to this copper oxide. That's a chemical test for oxygen. So the answer for the fifth part of the question was oxygen. And pure air consists mainly of two gases. Which is the most abundant gas in the air? Many people dropped the mark because they actually gave the two most abundant gases, and what you needed to do is you needed to give just the one. You can't hedge your bets and say, I'm going to give both of them and I'll get one of the marks. You can't. That's just incorrect strategy to use. The answer, of course, is nitrogen. For those people who gave both, if you then gave like the approximate percentages, if they were correct, then I awarded them up. So looking at roughly around about 78, 79% of the air as nitrogen. Pure water can be separated from seawater through simple distillation. Takes us back to Unit 2's work right at the very beginning of the year. So if you use a flame tester, and a lot of people just went into this, but talked about the method, but it says, how could you use a flame test to identify? That's not the same as describe fully all the steps that you need and the equipment that you need, the apparatus that you need and the steps that you need to take in order to do this flame test. That's not what the question is asking. The question is asking, how can you distinguish between sodium chloride and potassium chloride? Clearly, it's about sodium and potassium. So there were some long convoluted answers, but eventually, I read through that. They didn't get any credit for the method. If the question wants the method, it will ask you for the method. So that's my tip. Sodium comes up with like a yellow colored flame, but I accepted orange yellow because that seems to be the color that the textbook gives. But I will be emphasizing that whenever you are asked about sodium, just give yellow. I know what the textbook says, but when you see it, it's actually yellow. Potassium chloride, potassium ions, lilac. But I accepted purple, but lilac seems to be the agreed shade of the flame for potassium. It's interesting because this question over here actually is one of the early questions, but flipped around. So what you need to do is you need to have HCl acid. Nitric acid also works, and then you needed to use barium chloride, but barium nitrate also works because that's soluble. And so that's describing the test, and then the positive result for the second mark is that you get a white precipitate. Two essential steps in treating river water. The first thing is you need to do is you need to have filtration. There were some people that described sand beds and filter trap screening. That was absolutely fine. They picked up the one mark there. I was happy with that. The second one that you need to do is you need to specify chlorination. Chlorine is actually added, and then when we were covering the water supply and the preparation of water, a lot of people suddenly said, right, okay, well, all you need to do is just boil it. Yeah, that may work on like a small scale, but when we're talking about river water to make it safe to drink for an entire city, boiling the water is not feasible. So what you need to do is you need to sort of like scale it up, and chlorine is needed to kill off all of the microorganisms that could be harmful. And finally, why will these steps not make seawater safe to drink? A healthy proportion of students were able to identify. The reason why is because it still has the salt inside. It's still unsafe to drink because of the dissolved substances that are still remaining inside the seawater, the salt namely, because it would just not be safe for us to drink that way. And that's it. So there we go. The full review of the chemistry. Thank you very much for joining us. If you're from the outside, I appreciate it. And this is where I would expect people at the end of year 9 to be with Cambridge iGCSE. So take care, stay safe, and bye for now.